Welcome to EDU World Space.
Okay, so the equation from the book reads that theta min equals 1.22 times lambda divided by d. So for part A, all that we have to do is plug it in. We have the diameter and we have the resolution limit of the human eye. So directly plugging it in, we get theta I equals 1.34 times 10 to the negative fourth, or 28 seconds. Okay, so that's A. Now let's see B. Compare your answer in part A to the angular diameters of the moon and Jupiter. Okay, so what do we know here? We know that theta moon equals 2r divided by d, and that equals 9.0 times 10 to the negative 3 radians, and that also equals 1900 seconds. This means that theta moon to theta I equals 33.7. We also know that when Jupiter is at its closest approach to Earth, that theta Jupiter equals 2.3 times 10 to the negative 4 radians, and that equals 47 seconds. This means that theta Jupiter to theta I equals 1.7. Now, what do these values mean, this and this? Well, this means that the resolution is worse during all other relative positions. This is as good as it's going to get. Okay, now what about C? What can you conclude about the ability to resolve the moon's disk and Jupiter's disk with the unaided eye? Okay, well, we know that the disk of the moon, the disk of the moon can be resolved just with our eye. I mean, just go outside and you can kind of make these things out. However, the disk of Jupiter, the disk of Jupiter is around the same, or it's comparable to the resolution of our eye. What does this mean? This means that in order for us to really actually see any features or see any landscape, etc., on Jupiter's surface, those landscapes or features would need to be enormous. In other words, they would have to be about the size of Jupiter's disk.